Hello everyone. Today we move to the next exercise, and that is exercise 3I, page 27. We'll be solving number 1. We'll be solving the number 1A, 1E, and then I will leave the rest as usual for you to practice on your own. So it has instruction, and the instruction has to do with LCM. So find the LCM of the following. Leave the answers in prime factors. Now we are now in LCM, lowest common multiple, or least common multiples. So last class we talked about common multiples. So we said common multiples refers to the number that is common to 2 or more multiples of numbers. 2 or more multiples. We gave examples. So when we now say lowest common multiple, we mean the lowest number, the smallest number that is common to 2 or more numbers. So let's take a look at this one. The first one says 2 times 2 times 3, 2 times 2 times 3. So we have another one, 2 times 3 times 3 times 5. Then we have another one, 2 times 2 times 5. And we have to find the LCM, lowest common multiples. This, you will recall that we solved similar questions like this when we were under factors, when we are asked to find the highest common factors. We can also find the lowest common factors of this kind of number. So how do we do it? Is it the same way we did under factors, talking about the highest common factors? The answer is no. The answer is it's similar to some extent, but it has different conditions. If it is highest common factors, we will just pick the number that is common to all of these 3 expressions. We say 2, we take 2, then once we take 2, no other number that is common to the 3 expressions. So we will say that the HCF of these 3 expressions is what? 2. But when we say lowest common multiples, which is LCM, we will take these 2 also as 1. Then no other one that is common again. So this one, there is 2 here, we take it as also 1. Here there is 3, we take it as 1. And here there is 3, we take it as also 1. In fact, in lowest common multiples, all numbers are considered. So this also, we take this 5 as also 1. And our final answer will then be 2 times 2, which is 2 to the power of 2, times 3 to the power of 2, times 5. We can express it to the list to get but we are asked to leave our answer in prime factor, so we can leave it this way. There is another method to solving this. And the method is just expressing each of these expressions in what? Index form. For example, this can be expressed as 2 to the power of 2 times 3. This can also be expressed as 2 times 3 to the power of 2 times 5. Also, this 2 to the power of 2 times 5. We can get the LCM also. You will recall that we did something like this also when we are discussing factors, highest common factors. Then we said, for us to find the HCF, we pick look at this one has double 2s, 2 to the power of 2. This is 2, single, double 2. We will now say that since single 2 existed here, it also existed here. We pick 1. That is what we did under HCF. But the LCM, we will take every numbers inclusive. How do we mean? Here we will take the highest power of 2. Unlike the HCF, we take the lowest power of 2. The lowest power of 2 is what? 2 to the power of 1, which is 2. But the LCM, we take the highest power of 2, meaning we will take 2 to the power of 2. We now move to the 3. The one that is highest power here, the 3 that has the highest power is what we will also take, which is what? 3 to the power of 2. The same thing applies on the 5 that has the highest power. You know that is what? Just 5 to the power of 1. We say that is our final answer. That is just it. This is another method, most especially using the index form method. So let's now move to the E part. In the E part, we will also solve it using both such methods. Let's quickly go there. So we said the E, we have 2 times 3 times 5. Then we have 3 times 5 times 7. Then we have 2 times 3 times 3 times 3. Then the last expression, 3 times 5 times 5 times 7. So to find the LCM, so we look at the number that is common to all. You see that 3 is here and it is also here. So we consider those 3 that is common to all of these 3 expressions as 1. Then we now move on. Here is 2. There's another 2 here. We take it as what? As 1. So we have 2 there. Then we also what? What is it again? We have 5 here. 5 is here. 5 existed here. So these 3 5s, we take it as also 1. Then we have 5. There's another 5 there. We take it as 1. Here we still have 7. 7 is still there. We take it as 7. Then there is another 3 here. We have 3 here. So these 2 3, we take them singly. 2 3s. 2 3s. Then we also, what is next thing to do? I think we are done with everything. So we can now, since they said we should take it as what? Leave our answer in 10 factors. So we have 1 2s. How many 3 do we have there? We have 3 3s. 3 to the power of 3. And then we have 2 5s. 5 to the power of 2. Then we have the 7. So we say that is our final answer. So let's take a look at the second method. The method 2. The method 2, as we said, we express each of these something in what? In index form. 3 times 2 times 5, these are all in index of 1, power of 1. The same thing applies 3 to the power of 1 times 5 to the power of 1 times 7 to the power of 1. Then 2 times 3 to the power of 3. Then we have 3 times 5 to the power of 2 times 7. So the LCM. We pick the number that has the highest power. Let's start from the 2. 2 has the highest power of what? 2. 1. It has the highest power of 1. We take it. We also move to 3. 3 has the highest power of what? 3 to the power of 3. We take it. What about 5? 5 has 5 to the power of 2. What about 7? So we have 1 7. I think this one is even easier to solve than this. So here it is. Thank you for watching. So join me in the next number in the same exercise.